Welcome and good afternoon, everyone. Welcome to another Lunch and Learn webinar with WhyMaker. We are so glad you could join us today. My name is Alejandra, your host. Today, we are thrilled to introduce you to this month's featured vendor, Edm8ker. They are a global maker education company headquartered in Singapore and operating in the US, Japan, and beyond. They have partnered with schools and educators in over 60 countries, bringing hands-on, future-ready learning to life. Their approach is founded on nurturing a maker mindset, not just teaching content, but cultivating curiosity, creativity, critical thinking, collaboration, and resilience. Some of their key offerings include mobile, uh, makerspace solutions, their Maker Cart, AI-enabled teaching assistants, their Eddy, teacher professional development through their the trainer, makerspace design, and consultancy. What sets them apart is the integration of making plus digital tools plus real world problem solving. Their programs go beyond isolated STEM activities. They connect learning with meaningful challenges and bring student voices and choices into the process. Now, to bring these ideas into practical view, I am delighted to introduce our guest from Edm8ker, Terrence, who will walk us through how their Maker Cart, Eddy, and other solutions are showing up in real classrooms, share some case studies, and surface best practices for classroom integration. Terrence, thank you so much for being here with us today. Now, before we begin, a quick note. We will save some time for a Q&A session at the end, so please drop your questions on the chat as we go. Also, following the Q&A, we'll have a fun segment, our giveaway wheel. Once one of you will win an educator starter kit provided by Edm8ker. So now, without further ado, let's jump right in. Terrence, the floor is all yours.
Thanks, Alejandra. I'm really honored today to be able to share a little bit about our philosophy in maker education, and hopefully some tips and tricks on how to integrate MakerEd into your classroom. But a little bit about myself. So my name is Terrence, and I'm part of the Edm8ker team here at Edm8ker. Thanks all of you for coming to my webinar. And one of the things that really inspires me is the whole idea of, well, when maker education is introduced into the classroom, you can see students' faces really light up, as you see in the photos here. And what energizes me is kind of working with teachers and students to make that happen, to kind of scale that throughout our education system so that all students get to benefit from maker education. By the end of today's webinar, I hope that all of you will be able to, number one, explain how MakerEd boosts engagement and some workforce ready skills. Secondly, to see how our solution, the Maker Cart, solves logistical challenges with a portable classroom ready design. Thirdly, you're going to master three different approaches to fit making into your curriculum. Fourth, we're going to walk through one of our most favorite lessons, one of our most favorite maker activities, the Scribblebot, that's aligned to curriculum standards. Last but not least, we're going to access free MakerEd lesson plans and identify some grant opportunities that are on the horizon for you. But first, a little bit about Edm8ker. Um, we exist to empower educators like yourself with the confidence and tools to lead in maker education. Like Alejandro mentioned, we were founded in Singapore in 2016. By the 2019, we conceptualized the Maker Cart. It was tremendously popular in Southeast Asia during the pandemic, as it was a way for teachers to introduce MakerEd into the classroom without external vendors coming in into the school, right? We shipped our first Maker Cart to the US in 2023, and I'm proud to say that as of this year, we have sold our 200th cart. You can also see that we partner with different NGOs, partner with different corporate organizations to scale our work globally. So before I go on, a question that some of you might have is, what is MakerEd, right? And I think this is kind of important for us to have a common understanding around what maker education is. My philosophy is that it's a pedagogical philosophy that suggests that students learn best by doing, by experimenting, and by iterating. And it's at the simplest level, we know that students learn best by doing this, right? But effective maker education isn't just about putting a 3D printer in the back of your classroom, right? We like to use this frame that you can see over here, and it's really effective maker education is the intersection of three specific elements, right? You look at the blue. Give me one. Okay. Hmm, Sorry. Sorry about that. Within the blue circle, you see that this is really the hands-on part, right? Giving learners a choice, a voice, allowing them to build real-world skills and just memorizing different facts. But that's really just the start. Effective Maker also involves the community, which is the red circle over here. Making is an inherently social enterprise. It's collaborative, it's about open sharing, and we want students to be able to learn from each other, not just next to each other. And last but not least, and perhaps the most important, is about their mindset, right? What mindset are students really going into the classroom when they're attempting a maker activity? This is where we build resilience, where we build a sense of agency and a growth mindset, so that when a student's prototype fails, and it will, right, they develop the ability and the mindset to be able to fix it, right? An effective maker education happens right here in the middle. It's where hands-on activity, right, meets a supportive community within the classroom and beyond the classroom, as well as a resilient mindset. So that's our philosophy on what maker education encompasses and involves. A common question that we often get is, in this age of AI, and digital technology and all that, why is maker education still important? Um, and we think it's important because of three reasons, right? Firstly, it helps to develop workforce ready skills. There's a skills gap between what employers are looking for and what graduates have. And we know that modern jobs don't need just technical skills, right? They need human skills like analytical thinking, resilience, and curiosity. And this is what MakerEd helps to build. Beyond that, it also helps students achieve deep learning, right? Maker education isn't just play, right? We help students climb Bloom's taxonomy from remembering all the way to at the top, we have creating, right? And there are studies out there, that show that maker-centered classroom have significantly high motivation towards science. When students are making and creating, they're actually required to apply what they've previously learned, to remix and to analyze so that the artifact that's produced requires them to synthesize what they know about a topic. Last but not least, it helps to, well, it can promote purposeful community and social engagement, right? It leads naturally into community impact. And when students move from playful making to making for the community, they're actually leveraging their skills to solve real world problems. And in this photo over here, I have a school that we were working with a while back. And these students actually leveraged the design thinking process to create a shoe with a replaceable sole to address the challenge of sustainability in the shoe industry, right? And this is really one of the ways that maker education has the potential to help students transition from hands-on making to making for the community. And so Maker Ed really helps to empower students to become STEM creators, right? Not just consumers. But at the same time, we know the reality, right? I think all of us know the reality. Tech fatigue is real, right? Coming out of a couple of years of the pandemic, students crave connection, and this is where Maker really shines. But for many teachers, it often means weekends, spent cutting cardboard, organizing messy supplies, and that also is kind of taxing. And last but not least, fitting in a hands-on activity in the curriculum can be challenging in an era where so much focus is placed on standards, grades, testing, and all of that stuff, right? So we know that teachers need low lift moves, right, to bring MakerEd into the classroom without the burnout. So I'd like to introduce our Maker Cart as a solution to some of the challenges we saw in the previous slide. Our Maker Cart is a portable, lockable, classroom-ready design featuring customizable activities, supplies for over 80 students, and it includes all the lesson and instructional materials you'll need. It's a turnkey solution for all of your Maker needs. You get to choose 4 activities per Maker Cart from our catalog of more than 120 options. And most of our activities are aligned to standards in ELA, math, science, and social studies. We provide the supplies, the slide decks, the handouts, and the lesson plans so that you can focus on teaching in the classroom. And with the Maker Cart, you get to build, or your students will get to build, artifacts and creations like Rudolph over here. So Rudolph is my automata, and I hope you can see him. It operates via a crank and shaft mechanism such that when the student turns the crank, the object at the top rotates, right? And so this is really interesting. This is a really cool activity to teach principles of moments, principles of mass and energy conservation, right? So that's Rudolph. And another activity that we have as part of our Maker Card catalog is Scribble, right? So Scribble is a scribble bot, right? And when Scribble is turned on, the rocker at the top is vibrating, and because of that, it's able to draw and scribble using the markers that's connected to the bottom. So I'm going to go into a bit more detail about how you can integrate Scribble into your lessons by using one of our activities, by using our instructional material to kind of unpack how this activity works. But the Maker Cart as a whole, it's proven to work, right? So we've implemented this statewide in Iowa. We were involved in the STEM Scale Up program across 72 different sites. And it's also been featured in the Cambridge Harvard Summer Academy that was co-organized by the Harvard Graduate School of Education and Cambridge Public Schools. This is one of the activities that was created by the students. You'll see over here, it's one of our jitterbots. And the jitterbot uses principles of magnetism to create, well, a playful artifact that really kind of, as the name suggests, jitters and wobbles across the different magnets. All right. So we're going to deep dive into one of our activities, a Scribblebot activity. I'm going to bring back Scribble over here. So we're going to be looking at Scribble for the next 15 minutes or so. I'm going to play a short video on how the Scribblebot works. So give this a look. Okay. So that's how Scribble works. And so we use this as a hook, right? We often try to use this as a hook for our, oh, sorry. We use this as a hook for students to try to get them to think about, wow, this is cool. How does this work? Try to get the questions out, right? Before introducing the different components of a Scribblebot, right? We ask how do the different parts of the Scribblebot kind of work together, right? And we use this image as a way to get students to unpack the different aspects of a Scribblebot and how each component contributes to the overall function. We also like to use thinking routines. And one of the thinking routines we introduce at this stage is one that's called parts, purposes, and complexities. Right. In this thinking routine, students identify the different parts of a Scribblebot. Based on the slide over here, they can see that the different parts include the motor, the body, the markers, and so on. That's the parts. Purposes. For each part, they identify different purpose. For example, for the markers, the purpose of having the marker on the Scribblebot is so that it can draw and sketch on the paper, right? That's the purpose. And in the last column, we get students to write complexities. Or for younger students, we get them to think about how the different parts interact with one another. And so for the marker, students might write that the way it interacts with other components is that when the rocker is, when the motor is turned on and the rocker is spinning, it causes the Scribblebot to vibrate and it helps the markers move on the paper. So that's a way of getting students to think about different components within the Scribblebot and how they sort of interact with one another to achieve the outcome. Well, we provide different resources for this activity, including a teaching deck, different activity supplies, a student handout, as well as a teacher guide, so that it's really a plug and play model of implementation where teachers are really taking this activity into the classroom and being able to implement it using the materials that we give you. Skip this. Yep. So I talked about parts, purposes, and complexities just now, right? And so this is the table that we normally use. We get the students to write down different parts. We get them to write down the different purposes of each part, as well as sketch out how it interacts with other parts. And thinking routines like this are a really powerful way to get students to think about how complex components of a maker activity like this interact. And after students have kind of mapped out or have taken an initial stab at mapping out the parts, purposes, and complexities, we then guide students to explore the motor and the battery first, right? The key question here is how do you connect them? And this helps students build the understanding of a simple electrical component even before they build the robot, right? And in this part of the activity, what we're trying to get them to do is take the motor, connect the wires to it, and connect the battery pack. Then they turn on the battery pack and see what happens to the motor. The emphasis here is really on connecting a simple electrical circuit so that they understand what connections are necessary in order for the Scribblebot to work. And then the teachers play the video and get students to refer to the handout that's provided to them in order to complete the hands-on activity. After students are familiar with how a basic electrical circuit works, we introduce the design challenge along with the criteria and constraints. And for those of you who are listening to this who are familiar with the engineering design process or NGSS engineering standards, criteria and constraints are super important for students who are doing STEM projects, right? And so we tell students that your task is to design and construct a Scribblebot like this that can draw a pattern across a sheet of paper. We present different criteria that their scribblebot needs to be stable, it shouldn't tip over easily, and it should be able to draw, sketch different patterns, right? And that helps them focus their design and focus their build. Now, after introducing the criterion constraints, this is where it transitions more into a student-directed learning experience, where the students are using the materials to build their bot. We have a timer presented on the screen, right, that counts down for 30 minutes to make sure that students are focused. But at this point, students are mainly engaging with their handout that gives them a step-by-step process about how they're going to build their Scribblebot. The role of the teacher at the stage is more of a facilitator rather than a sage on the stage. So I want you to imagine the students all grabbing different materials, starting to piece together their Scribblebot, while you as a teacher are walking around, observing, and supporting students who might be facing challenges by asking questions, by giving provocations, and really helping them refine their artifacts. These are just some more steps that's given to students as they are building their bot. And at this point, I think one thing I want to highlight is the importance of visual signposting, right? It's really important. We think it's really important to provide these different icons as ways of signposting what we want students to do or how we want to guide students in attempting the activity. So we have a number of icons. I put four of them over here. Think is when we want students to think more in a more open-ended fashion, right? We want them to think divergently, and we wanted them to think in a more, I guess, maker-centric mindset, right? Safety, as the name suggests, it's where students need to attend to certain aspects that require them to be safe in the classroom. We also have different tooltips that flag out where something is important, or in the case where a step might be a little bit more challenging. We instead of giving them the answer or telling them how to do something, we prefer to give them a hint, right? That tells them, is this something that you've been thinking about? Why not try a certain why not try a certain approach? Or why not try this tip, right? We give them hints to scaffold their learning while not presenting them with the answer. After they've created and built their bot, the next step is for them to test and improve. And this is a super important part of the engineering design process, right? We give them different hints and tips that are tailored to each specific activity to get them to think about how they can actually improve their functioning of the Scribblebot. At this point, we often like to tell students that nothing is perfect the first time you do it, right? So you want to iterate, you want to try something again, you want to test it out, and these hints are so important for you to kind of tailor your design and tailor your bot. We also provide scaffolded steps on the right to get them to really look at the criteria and constraints that we mentioned earlier and use those criteria and constraints to test their bot. So, for example, questions like, does your Scribblebot tip over easily, right? And if students say that, for example, my Scribblebot is tipping over a lot or it always falls over, then that's a good opportunity for you to go back and say, okay, well, let's look at the criteria, right? One of the criteria that we said earlier is that it has to be stable. If your Scribblebot is tipping over, right, what does that mean about the way you have designed? What does that mean about the way that you have engineered your bot? And what kind of changes can you make to make it function better so that it meets our criteria and constraints? So we have 10 minutes of that rapid prototype, rapid testing and iterating. Um, it's also really important for students to come back in a small group or a bigger group to kind of share their learnings. Like this is one of the most important aspects of MakerEd. If you recall, one of the things I talked about earlier is that community element, how students work in groups, how students are able to function in small or larger communities. And this is an opportunity for them to reflect with their partner or their group about what changes they made to their bot, right? What was the hardest part of the activity and how did they solve it? And by addressing these questions with one another, you actually help to do a few things, right? You help to reinforce the idea that challenges are not, you're not facing challenges in isolation. You're facing challenges in a group and we solve them together. But also for students to kind of learn from their peers about something that they might have tried and if students want to say, okay, well, you did something cool. I want to adopt that in my design and my build, right? That's something we want to see in a classroom. The idea of like open sharing, whatever iterations that I'm doing to my bot do not belong to me. They belong to the wider community. And this is just a way of promoting that broader culture. And then last but not least, optional, this is an exit ticket that we get students to complete individually before leaving the classroom. So often we talk about assessment of learning, right? There are these formative assessments that happen as a facilitator is walking around, observing, and giving students feedback. But this is a small summative assessment at the end that we can use to determine how much a student understands or understands the activity and the principles behind the activity. So that's really how we, oh, there we go. So that's really our approach of tackling maker activity, right? And although I've grounded this sharing in the context of a Scribblebot, this arc, right, this teaching and instructional learning arc applies to all of our 120 different activities. Okay, so now that I've gone through, how a maker activity looks like in our context, I want to talk a little bit about creating curricular connections, right? And how an activity like the Scrollbot over here can be infused into your classroom, whether you're teaching science or English or other subjects. And why is this important, right? Often we're seeing that maker activities like our Scribblebot are not used in isolation. They're often deployed as part of a bigger unit of study, often in project-based learning. And even for teachers who are STEM specials, increasingly there's a greater focus or emphasis on interdisciplinary and cross-disciplinary contexts, where STEM special teachers have to integrate or connect with other teachers and their colleagues to make sure that a STEM specials lesson is making those interdisciplinary connections with math, with English, or with other academic subjects. Even when these projects are used in an informal learning context, for example, in an after-school learning context, making clear what these curricular connections are and having a sense of how it connects to what students might be learning in the formal classroom can often help to serve the bridge between informal and formal learning, right? So that's really helpful for teachers who might be working in more informal learning contexts. And so, for the next 15 to 20 minutes now, I'm going to go a little bit more into detail about how you could connect an activity like the Scribblebot into your scope and sequence, focusing first on standards, right? So, often a question that we get is, Scribblebot's really cool. How does it connect to my standards, right? And so I'm going to share from a science perspective, how you could connect it to some of the NGSS standards. These standards that I have on my screen over here are from the grade 4 standards. And you can see that um, at grade 4, what students need to be able to do is to be able to apply scientific ideas to design, to test, and refine a device that converts energy from one form to another. And this is a standard that the Scribblebot really excels in. When students learn about principles of center of gravity, balance, and energy transfer, what they're really doing is creating an artifact that speaks directly towards this standard, right? They're designing, they're testing, and they're refining a Scribblebot like this that is actually converting energy from the battery in the form of chemical potential energy to electrical energy and then to kinetic energy in the rocker, right? So this is a really appropriate activity for this standard. At grades 3 to 5, NGSS also requires students to there's a set of engineering and technology standards, right? ETS 1 to 1 all the way down to 1 to 3, right? And 1 to 1 says that students need to be able to define a simple design problem reflecting a need or a want that includes specified criteria for success, as well as constraints on material, on time, on cost, right? And this is where what I mentioned earlier about the criteria and constraints are really important. That specifying the criteria and constraints as we do in our instructional content is really important to keep students focused, right? And so you could even introduce your own criteria, right? Your bot must be able to draw 10 inches in 20 seconds. The emphasis is really on imposing these criteria so that students can really be focused on what they're building and creating. Um, so that's for ETS 1 to 1. ETS 1 to 2 and 1 to 3, I like to take them together, right? 1 to 2 says that students have to generate and compare multiple possible solutions to a problem. On the other hand, 1 to 3 requires students to carry out fair tests in which variables are controlled and failure points are considered, right? An activity like a Scribblebot is really useful and can be modified so that students are meeting 1 to 2 and 1 to 3, right? Um, for 1 to 2, they need to be able to compare multiple possible solutions, right? So for example, asking students, what if I add another battery pack, right? This is a battery pack. What happens if I add another battery pack? What happens if instead of a piece of cork over here, right? I'm using another um off center weight. That's what we call it. Or what if we use an off center weight and we don't put it in at one side? What if we put it in the center? What happens, right? What if we change the center of gravity of the Scribblebot, right? All of those ways or all of those questions are provocations for students to compare multiple solutions to a problem, and from there observe how well each solution can kind of tackle the problem, right? And when they control one variable and modify other variables and document all of that to observe how the Scribblebot functions as they change different variables, they're also carrying out fair tests, which align perfectly to ETS 1 to 3, right? So that's that's an overview of how an activity like the Scribblebot can be connected to some of our NGSS standards that are so important for teachers today. But beyond that, beyond NGSS standards, within our ELA standards in Common Core, there is also a huge emphasis on, uh, sorry, within ELA standards and Common Core, activities like the Scribblebot can also be aligned to those standards. We have a couple over here that we align to our Scribblebot activity, right? For SL 4.1, we're getting students to engage effectively in a range of collaborative discussions with diverse partners, right? And for for this standard, that calls students to make, not just make, but share and reflect with their peers, right? So if you recall, the time that's given close to the end of the lesson for them to share about their maker experiences with their peers, with their partners, or with their classroom, powerful opportunities for you to really hit this ELA standard so that students can engage in these discussions and build their language ability in addition to these SEL components of open sharing and collaboration that are so important. RI 4.3, on the other hand, says that students need to be able to explain events, procedures, ideas, or concepts in a scientific text, right? And so for this standard, um, we address it, or we try to address it, by looking at how our um, design of the instructional material is done, right? When students are reading, interpreting, and unpacking the content of the handout, and they're unpacking the content in a way that they're able to build their artifact, their Scribblebot, they're actually applying what's the skills that are called for in 4.3, right? They're unpacking the events, procedures, ideas, or concepts within the handout they're given, and they're using that information to produce an artifact that's they can call their own, right? So when students do that, they're actually tackling this particular standard. Now, apart from engaging with NGSS or Common Core standards, right? I also want to suggest or put forth another framework that is useful to help you think about how an activity fits into your scope and sequence in the classroom, right? And this is a framework that was released by MakerEd, the organization that is the organization behind much of maker education research, right? And what we like to think of as this framework incorporates three different aspects or three different ways an activity can be integrated into the classroom, right? We have Tinker Discover on the left, where learners are developing an understanding through tinkering and making. Learners work through short-term goals and make meaning of their discoveries. Then we have Make to Learn in the middle, where learners are building on and deepening their understanding of making, and this helps to cement their understanding of content. And last but not least, we have Application Project, where learners are applying their understanding in order to complete a specific project and showcase their learning. Now, these three maker approaches taken together provide a framework for you to think about how you can integrate an activity like the Scribblebot into your classroom. And here's how. If you were to integrate the Scribblebot activity as a Tinker to Discover activity in your science classroom, you might say this. Here's a mystery box containing different things like a paper cup, a DC motor, and other interesting items. In a moment, I'm going to show you a video of a Scribblebot, and I want you to pay attention to the movement of the bot. Your task for today is to figure out how to use the items that you have to create a robot that can wobble and scribble like the one you've seen, right? And so this is actually an activity that's introduced at the start of a unit for students to discover through trial and error that a closed path, a closed circuit is needed for the motor to run, and an off-center weight is needed for the bot to wobble. And the objective of introducing this at the start of a unit is to assess their prior knowledge. How much in this case do they already know about circuits? As well as a hook activity to build curiosity and to engage students at the start of the unit, right? We want them to ask questions, right? We want them to ask, why is it that the battery needs to be connected in order for the motor to run? We want them to ask big questions like that to help to ground their understanding and to help to ground their curiosity so that later on in the unit, these questions can be revisited and answered. So in this approach, right? The emphasis is on open-ended exploration, like I've mentioned earlier. It's most relevant at the start of a unit when you want to introduce a concept without a lot of prior knowledge. And students might have different ending points, right? Some students might be able to get the entire scribblebot to work and function. Some students might be able to get the battery pack connected to the scribblebot, but they don't have time to build the entire scribblebot. And some students might struggle, right? Frankly, with even getting the connection set up, right? But some form of group consolidation through this activity will allow all students to learn in a Tinker to Discover activity, right? And this is especially useful. I've seen it used in a fourth grade science unit where the teacher used it to introduce a circuitry unit, right? A circuitry concepts. So that's Tinker to Discover, right? You use it at the start of a unit. Now let's go on to Make to Learn, right? So Make to Learn is a second approach, right? And the way I would use Make to Learn if I wanted to bring in a scribblebot in this same um, science unit is to say this, right? So far, we've learned about basic concepts like open and closed circuits and energy transfer. Today, you'll apply this knowledge to build your own scribblebots. You'll be given some materials as well as a step-by-step guide on how to assemble your own scribblebot. And this guide will also help you to troubleshoot the most common errors that you might face. And the focus of this make to learn activity, right, is for students to apply the skills and principles that were taught earlier through explicit instructions and a set path for all learners. In this case, after students learn about circuitry and a complete circuit, they then apply those skills to build a functioning scribblebot and connect the battery pack to the motor, right? They're applying what they previously know about circuitry and about electricity, right? Um, in this approach, we are giving students a set of instructions, a handout that allows them to, a scaffolded handout that allows them to build a scribblebot um, by the end of the lesson, right? So the intended outcome is for all students to be able to do it, right? And we need to be able to give them the support that's needed for them to do so. The emphasis in the make to learn approach is on deepening understanding, could be on correcting misconceptions, or some form of formative assessment, right? This is most relevant in the middle of a unit when you want students to apply what they've just learned. The making process is actually pre-scaffolded in this approach, but students will need to apply their own disciplinary knowledge for a successful project. So that's the make to learn approach when you want to use a hands-on makerette project in the middle of a unit. Now, what about at the end of a unit, right? At the end of a unit, you could use this last approach called application project, right? And the way I would do it for the school robot is so. I would tell students that their design challenge for the day, your design challenge for the day is to create a scribblebot that draws at least 10 inches in 5 seconds. So your scribblebot needs to scribble at least a distance of 10 inches in total within 5 seconds. So you can use the materials that are given to you, right? Whatever we give to you, as well as anything else you can find in your classroom. In pairs, you'll then create a short presentation explaining how your specific design choices help you achieve your challenge goal. And this will require you to draw on as well as integrate your existing body of knowledge on circuitry as well as forces and motion. So this is a summative assessment because the artifact in itself, as well as the student explanation, whether it comes in a form of a presentation, a write-up, or any other form of presentation, right? This is an assessment that that serves as an assessment that assesses how well they know their existing disciplinary knowledge that has been taught within the unit, right? And students may add more batteries, they could adjust the offset weight in order to meet the design challenges. And all these are design decisions that they'll need to back up using evidence, using their knowledge and what they've learned in the unit so far, right? For example, they might say that, well, I want to add another battery pack because that will cause the motor to spin faster and it'll cause the um, screw up to rock in a more violent or more aggressive fashion. And that will help my robot kind of draw a longer distance within the set amount of time, right? The idea is they have to draw on what they know. They have to draw on what they already learned in the unit. They have already learned in the unit to enhance or make changes to their screw robot to improve its performance. And so, yep, like I said, the application project is really the emphasis is on summative assessment and knowledge synthesis. And this is most useful at the end of a unit. Like the exact making process is open-ended, which forces students to apply and blend what they have learned across the unit to complete the project. And for example, this scribble activity has been used in a high school science unit at the end of a unit that blends forces as well as electricity, where students need to apply what they know about mass, about center of gravity, and other concepts related to forces, along with what they know with electricity, right? Circuitry, transfer of energy, and creating a complete circuit. So to summarize, right, when you're deciding how to fit a maker activity like this robot into your own scope and sequence, these three approaches are ones to consider, right? You can introduce it as a tinker to discover activity, introduce it at the start of a unit as a hook. If you want to use a make to learn approach, you introduce it in the middle of your unit as a formative assessment. Last but not least, if you want to introduce it as an application project, then you'll do so at the end of unit as a summative assessment. And as I'm coming to the end of my sharing today, I just wanted to also share that in addition to this recording, you'll be able to find the Scribblebot lesson plan as well as more than 100 other activities on Eddy. I'm gonna share my whole screen just to give you an idea of how you're able to access learning resources like this. Oh, let me share this window. There we go. So this is Eddy, which is Edm8ker's online content portal, right? And we use it as a way to share and disseminate our own instructional content. If you're interested in finding out the resources for Scribblebot, as well as more than 100 other activities, you'll click on this icon over here, Maker Card. You'll go to Catalog, and over here, what you'll see are all of our different activities, right? If I type in Scribblebot, click on this, I'll be able to see an overview of the Scribblebot activity. But more importantly, if I click on sample lesson materials over here, then I'll be able to see the materials that are provided within the Maker cart. But beyond that, I'm able to also see our slides that I've shared today. I'm able to also copy slide deck to your Google Drive. I'll copy the handouts, right? So you click on any of these, you can add it to your drive and copy the materials over. You can remix them, you can convert them, you can kind of like modify them according to your classroom profile. We love hearing how teachers have been using our content, so feel free to kind of reach out to us. And yeah, all the resources are here for you to adapt and use in your classroom. So if you're thinking about integrating Maker into your curriculum, get started with our Maker card. You can explore activities on our online catalog, as well as download the student handouts and slide decks for many of these activities actually on our online catalog on Eddy. WhyMaker is a great partner with us. So if you're interested in ordering one of our maker cards, you can actually submit an order via the WhyMaker site, and then you'll receive your custom maker card, right? It's as simple as that. We've also recognized that many teachers who might be interested in our maker card are actually interested in using it within their academic classroom, right? So we take the guesswork out. We've released a new series of Curriculum Connect Maker cards, which are aligned to different topics within a particular subject. So for example, we've released a math card where the activities in the math card are all aligned to math topics that your students will be learning in middle school, right? For example, this second activity over here, Crack the Code with Cipher Wheels, requires students to um, apply what they already might know about foundational algorithmic thinking to create a cipher wheel that can be used to encode particular messages, right? In this activity over here, cardboard capers, students build a cardboard maze, and they have to use what they know about angles, about geometry, about um, being able to about how different angles affect the reflection of objects, right? To design cardboard mazes for a marble to travel through. And this is where students are really integrating their disciplinary knowledge, like what they've learned within their academic subject, into a hands-on making context, right? Through either a think to discover, make to learn, or an application project approach. Last but not least, I know, some teachers that are listening to this might be interested in getting a card. Budget is, of course, always an issue, but I'm happy to share that there are various grants that are available out there. This is one of the grants that teachers have been interested in applying for to get a maker card. And so the Toshiba America Foundation has released STEM grants of less than 5K, and these grants are available for application every quarter, right? The next deadline is in, less than 2 weeks. So if you're interested, you can reach out to WhyMaker or reach out to us for support in applying for this grant. And yeah, that's really it. So maybe I'll just take a pause, see if there are questions, see if happy to address any questions from the floor.
Of course. This is amazing. Well, first of all, Terrence, you have been so good. This has been really insightful and just packed with practical ideas. Thank you for walking us through different ways that this can be implemented in the classroom, whether it is as a subject itself, like from the beginning, or incorporated in the middle of a unit, or as a project at the end. I think this is wonderful, and teachers just love to hear about this. Now, it is time for our audience to get involved, please, and go ahead and type any questions in the chat if you haven't already, whether it is about lesson integration, which Terrence was very thorough in that, thank you, any classroom challenges, makerspace design, or how to customize your kits and tools for your context. We'll do our best to go through them all. I do want to get started with a question. Uh, Pretty simple, I guess. Can any of the Edm8ker solutions, whether it is the maker cart and the Eddy, etc., be used in other subjects beyond STEM, like call it art, PE, social studies, music, history, and what have you?
Yeah, that's a great question. I'm going to share this screen and hang on a moment.
Hmm.
And the reason why I wanted to share Eddie again is because it allows teachers to, um, there we go. Here we go. It allows teachers to look at which maker activities might be most appropriate for different subjects, right? We have a
Hmm.
list of different subjects over here that we have mapped our different activities to. So to give you an idea, say for example, for social studies, give me a moment. Hmm. Okay. Well, for social studies, one of our activities around mask making, right? Um, let me pull it out. Okay, this one, right? This is one of the activities that we have where students are actually designing a opera mask after they learn about, what's the symbolism behind different colors and artwork that's used in picking opera, right? And after they learn about this art style and cultural form, they're actually welcome to kind of build their own masks using the resources that we provide. And I think this is a really powerful way of integrating some social studies, global culture elements into the classroom. Right. For math, I've given a couple of examples earlier where students are using geometry principles to kind of determine how they want to fold their cardboard in a cardboard maze or inform how they want to design their cryptography wheels, right? To give a bit more detail, right? When students are actually invited to cut out their cryptography wheels, it works. Let me pull it out. Yep. So if you see when students are actually designing their cipher wheels, they have to measure a circle and they have to split it into equal segments, right? Which require them
Right.
to apply some of their knowledge about angles, dimensions, 360 degrees. How do you split it into 15 degrees of equal width? There are 26 letters in the alphabet. So how many segments do you need to divide, a full 360 degrees into, right? So there are these like curriculum connections that are sometimes kind of overlooked, right? But it's a matter of what emphasis you want to place on the activity. And I think what we've been trying to do is be quite intentional and deliberate about how we draw up and develop our materials to tackle specific standards that we know are so important.
Beautiful. Yeah, I love that you bring up and that you were very thorough about the standards because it is very important. And when including these types of activities, we want to make sure that everything is covered, right? That we are assured that all of the standards are being met. Well, beautiful. Now that you are on the Eddie, let's talk a little bit about that. I do have a question about it. So, in what ways does Eddie, and this is coming from a former teacher, um, your AI teaching assistant essentially. How does it actually reduce like teacher load during hands-on projects? As we all know, teachers often juggle classroom management, troubleshooting, the project facilitation, all with the
Mm.
students, doing a project live at the same time. So how does Eddie support real world, like real-time instruction feedback and the differentiation during a making hands-on activity?
I'm so glad you asked that. Yeah. So our AI chatbot, his name is Edward. So you can say hi to Edward. Yeah. Edward is here at the bottom. He's here to help you. And this is something we've recently released in the past couple of months. But what it helps you do is once you're in a particular maker activity, Edward will be able to respond to any prompts you may have about the maker activity. Let's say, for example, you're doing a scribbleboard activity in a classroom, right? But you're actually not doing it for a science class, you're doing it for an art class, right? You can ask Edward, what are some changes I can make to my handout, to my slides that will actually tailor my content that I already have because it's accessible on Eddy. How do I how will it tailor my content to the particular student profiles and to the class I'm teaching, right? You can also ask Eddy things like, well, I have a class of 20. How many of each material is needed for this classroom, right? So you as a teacher can go and retrieve the necessary quantities of material before the lesson instead of having to do a whole lot of quick math. So these are just some of the capabilities of Eddie of Edward that we are kind of doing to make the experience for teachers a little bit more streamlined, right? Because like you said, right, I think giving teachers resources that they need is the first step, right? The follow-up, well, which has to be done at the teacher's level, is a whole lot of customization and modification because teachers, you know your classroom the best, right? So I see our job as helping to make that job easier for you. right? Not by giving you the answer, but by giving you an AI agent that's able to be a co-pilot and be a assistant to help you tailor that activity for your students specifically.
Awesome. Well, yeah, definitely. Edward sounds like the best teacher assistant. Um, I have one more question, and this is coming from me. I really like to ask our vendors while we have them on the spot, and this is just something that we love to hear. Um, in the time that Edm8ker has been delivering and offering their services. What kind of impact have you seen in real world classrooms? Like, we love to ask about what feedback you heard from teachers, from students, because I think that's very enriching, right? Like, from educators that use it in a regular basis. What is the one thing that you would feel most proud of that you've heard from teachers?
I'll give one from teachers, and then I want to show a short video involving a parent. Is that okay?
Of
Yeah.
course, please.
So from teachers, I think what something that really resonates with us is the idea that um, it helps teachers integrate maker education into the classroom, into, like I said, into the formal academic environment, right? Because and to just take a step back, I think a lot of times maker education is relegated, right? If I can use that word, right, to after school settings, informal learning settings, and so there's a perception of like, well, it's less important, right? It's not part of the formal curriculum, right? So our philosophy is that if we help teachers better integrate it within the formal curriculum, then it's going to be something. It's going to be an educational philosophy that is a bit more pervasive and is a bit more. It will affect or it will scale up to more schools and more students eventually. So one teacher that, when we were implementing our Maker Card in Singapore, and this school has come back to us for 4 or 5 years now, right? With different orders, with different activities. They have used it, not just, they started off by using it in an after school setting, right? But after seeing how students kind of responded to it, then they decided to introduce it within the formal learning environment, right? So if I were to enter a classroom in that school, I would see a maker cart at the back. A teacher might be teaching an English lesson on creative writing, right? Or composition skills, essay writing skills, right? But in between and after teaching a topic on essay writing, students would go to the maker cart, retrieve materials, and maybe do up a little tableau about what they've written about the essay. So they're connecting, the skills, the content within the essay, the actual skills of making and creating, right? So there's this whole connection that exists. And I think when teachers say that they're able to do that, and they're able to articulate the kind of excitement and engagement that happens with students, as well as the deep learning that happens because they're so much more engaged, that's something that really speaks out to me. Um, and so that's something that we've seen again and again. Um, as for parents, I want to show you. So some of our strongest kind of like testimonials and support have come from parents, because I think they are the ones who are with their students for so often and with their children for so often. And when they see the kind of impact that maker education has on their kids, it can be quite transformational. So I'm going to show a short clip. I can share my sound. So just to give a bit of context, right? This is
Meet Sahar and her
we did a scoreboard activity with one of our students. So parents would bring their kids along, and we were actually facilitating a short activity around that. So I just wanted to share a little bit about what Sahar, who's the parent over here, is sharing about how this activity impacted her child.
Meet Sahar and her son, Omar. He's 5, full of curiosity, and always up for something new. What started as a simple activity with motors and markers turned into something much deeper. Watch their full interaction to see what real learning looks like through the eyes of a 5-year-old. Spoiler alert, it involves scribble bots, smiles, and some serious problem solving. Let's roll.
Yeah, so can you share a little bit about what we did today and what Omar actually did with us today too?
I think the basic purpose was to reflect our identity by making robots. we had some kind of stuff like batteries and markers and all this stuff. We created, what do you call it, robot? Scribble bot. And I think Omar enjoyed it so much. This is his first time using this kind of activity, and he's interested in it. It's gonna stop working if you do this. Yeah, and I think it is a very interactive way to teach kids. And I would want it more in classrooms. This generation wants more than just writing pens and papers. They want more interaction. And just like this Sonic, Omar got really interested because it involves his interests. And yes, it is.
Thank you. Would you do something like this at home? What kind of resources and how would you like to find out how to do similar activities at home with him?
I'm literally thinking about doing it because it does not involve a lot of stuff. It's pretty simple, pretty much stuff that you can find in your home apart from this battery. So I think I might want to improvise it with him at home with his dad,
Very
working
nice.
with us. So it would be nice. Yeah. Yeah. Yeah.
So I'll just take a pause there, but I think you can see the sort of excitement and engagement that I think the students have, but also the parents and teachers really recognize that this sort of hands-on learning is important to build some of the skill sets that pen and paper instruction or direct instruction with teachers standing in front of the classroom that can't really give you, right?
Correct. No, and you mentioned something very important too, that having this kind of support from parents, just them being on board, and it's transformational because they continue the children's formation and education at home. So if they can take this and continue that, that also keeps, just making a well-rounded system for teachers, parents, and the student, of course. Well, thank you so much. This has been such an enriching session, Terrence. Very much heartfelt thank you to you and to all of the EdMaker team for sharing both the inspiration behind your work and the practical approaches for integrating maker education. This has been amazing. And also thank you everyone for being here, for your thoughtful questions, and for enthusiasm. Now, for further explanation of EdMaker, uh, as Terrence mentioned, you can now find them on the WhyMaker website as well as their own, and also can follow. We encourage everyone to follow on social media for EdMaker and for EdMaker. Also, don't forget to subscribe to our weekly newsletters for updates, new resources, and our upcoming webinars, as you can see on screen now. Thank you, Terrence. Yeah, here are the social media handles for anybody who would like to follow. Now,